VSS Monitoring's podcast series. The podcast series dedicated to helping you, the network professional, increase visibility to all of your users and lowering your costs while doing so.
Hello, ladies and gentlemen. Welcome to VSS Monitoring's monthly podcast. My name is Mark Ilarucci, and I'm an account support engineer here at VSS. I'm joined by Brett Green from the engineering side of the house. This month's topic is timestamping. Timestamping is one of our packet optimization technologies. Packet optimization is a hardware-based packet modification with multiple options available. Packet modification can be enabled or disabled on the fly and allows for enhanced traffic grooming. I'm going to hand it over to Brett Green to give you a little more information about timestamping.
Today we're going to discuss timestamping NTP edition. In timestamping, a packet is timestamped on ingress into the tap. An 8-byte stamp is placed after the data payload and before the CRC inside the packet, and this allows for multiple monitor tools to access the timestamp data. The first 4 bytes of the timestamp are representative of seconds, and the second 4 bytes are representative of nanoseconds. Then the CRC is recalculated and a standard Ethernet packet is formed. Timestamping only occurs on the monitor side of traffic. Network traffic is completely unaltered. Timestamping is easily configured via the graphical user interface. First, you set an NTP server in the tap, and then you can enable timestamping on a per-port basis on the network side of the tap. Each individual network port can be configured to enable or disable timestamping. And again, that timestamp is only inserted and sent out the monitor port. Any inline loop through on the tap does not have the timestamp packet. The original packet is always preserved 100%. Here's a classic example of using timestamping in a monitoring deployment. We have a completely passive inline fiber solution for 10 gig networks. A packet is traversing the completely passive 1x1 fiber tap and enters the 4x24 tap at, let's say, time 0. The packet is stamped with that time of 0, and as it traverses the tap, through filtering, aggregation, load balancing, and any other features, that timestamp is preserved and time 0 is in the packet as it passes out the monitor port. As you can see, timestamping has many benefits. You no longer need for a monitor tool to apply the timestamp, and this inherently avoids any problems with latency as the packet is passed through the tap and through the monitoring tool and then stamped. Now you have an accuracy based on the network input side. The moment the packet is input into the tap, it is stamped, and that time holds true all through the process. This is ideal for latency-sensitive monitoring applications.
Thanks, Brett. And that concludes our monthly podcast about timestamping, a packet optimization technology. For more information, please visit us online at www.vssmonitoring.com or give us a call at +1 650 697 8770. From Mark Ilarucci and Brett Green here at VSS, thanks for your time. We'll see you next one.